Greetings of the day. Welcome to Electrified at IIT Delhi. I'm Abhrodip Chaudhury, and today we'll talk about a capacitor-coupled SEPIC and Ćuk based successive folding inverter for PV systems. Let's get into it. Before talking about a successive folding, let us discuss an unfolder inverter. This is a 1 kilowatt unfolder prototype developed in the lab. Traditionally, an unfolder inverter has two stages. In the front end, a high frequency DC-DC stage takes a stiff DC input and creates a pulsating DC akin to a DBR output at the intermediate DC bus. Then a full bridge inverter stage creates a pure sine wave by switching at line frequency. So let's see the unfolder in action. If you focus on this intermediate bus voltage, we can see that the double line frequency is retained, reducing the intermediate bus capacitor size. Also, the sinusoidal output voltage and current helps in the reduction of output size filters, attenuation of leakage current in the case of transformerless PV systems, and reduction of cable reflections in the case of use of long cable. On moving to higher power, the folding stage requires isolation. This can be achieved by this dual active bridge type of converter, but the transformer increases the size and weight of the system, and the device count is also increased. The unfolder can be improved by replacing the traditional two-stage topology with a single stage whereby the reliability is increased and the device count is reduced. And the transformer isolation can be replaced with capacitive isolation so that the size and weight of the system goes down and the efficiency is increased. This is the proposed successive folding based topology, which is based on the SEPIC and Ćuk converters. SEPIC and Ćuk have positive and negative gains respectively, so the whole line cycle can be created without an unfolder. Also, there's innate topological symmetries help us to create the circuits from one single topology with the help of these routing switches, and the capacitor isolation is also easier to achieve. In the positive half cycle, the SEPIC converter is realized. It has two switching modes, and if we operate with a variable duty ratio, then the positive half cycle of output can be created. Similarly, for the negative half cycle, we can realize the Ćuk circuit and again vary the duty ratio sinusoidally so that the negative half cycle is created. So this is the output voltage of the converter and output current, which shows a very low THD and a sinusoidal profile. The capacitive isolation is also achieved as evident from these waveforms. This is the simulation waveform of transient conditions with transients in input voltage as well as load being shown. We can see that the converter output current is without any notches or overshoots, and the voltage profile is also not distorted. This is a 5 kilowatt converter prototype which is still under development and experimentation is still pending. Before we conclude, let me talk a bit about our research group. Under the supervision of Dr. Anandarup, our team is involved into cutting-edge research areas such as grid-connected unfolder with a PV system using single-phase unfolding, a battery pack assembly for an EV charging system, three-phase unfolder for motor drive applications, and fault-tolerant MMC converter for high-voltage, high-power grid applications. Some other interesting research areas are CHP STATCOM using IPM and virtual inertia control of a CHP STATCOM in a power plant dominated grid. These are some of our research collaborators. Thank you to IEEE IES for providing this interactive platform via the IEEE SYPA contest.